Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering a whole new topic called directory traversal. Just like with the other theory videos, this is pretty much a brain dump of everything that I know about directory traversal vulnerabilities, and so it's going to be a long one. But by the end of the video, you'll have all the fundamental knowledge that is required to complete the 6 hands-on lab exercises that we'll be covering in the next upcoming videos. Alright, let's get started. The agenda for today is to first cover the technical details behind directory traversal vulnerabilities. So what is a directory traversal vulnerability? How common are these vulnerabilities? And so on. Next, we'll cover how to find directory traversal vulnerabilities from both a white box and a black box perspective. So if you're given an application and possibly even the application source code, how would you approach testing the application to determine that it's vulnerable? Once you've found that the application is vulnerable, how do you exploit the vulnerability to achieve your end goal? Then we'll end the presentation by covering the different techniques that you can use to prevent or mitigate directory traversal vulnerabilities. Okay, let's get started with the first section, which is what is directory traversal? Directory traversal, or also known as file path traversal or just path traversal, is a vulnerability that allows a malicious actor to read files on the server that the application is running on. Let's take an example to better understand this. Imagine you have an application that allows you to view cat images. Now, the way that the application works is that when you visit a certain image in the application, it makes a GET request to the backend server that takes in the file name of the cat image that you want to view. The backend application processes that request, retrieves the file, and then displays it back to you in the browser, which seems okay. However, the issue is if this file name is user controllable, which it is because it is coming from the client side, and if it's not validated in any way in the backend, then you could view any file on the system that you want, not just cat images. And that's exactly what this attacker is doing over here. So instead of having cat.png in the file name parameter, the attacker is requesting the passwd file, which is a world readable file that is accessible by anyone that is on the server, including the application itself, which is running on the server. And so when you make this request, the application retrieves the content of that specific file and it displays it back to the user or back to the attacker in the application. And that's essentially how directory traversal vulnerabilities work. They're the type of vulnerability that is extremely simple to exploit once you find it. Okay, let's look at how these vulnerabilities are introduced in code so that we have a better understanding of the technical details behind this vulnerability. I would say the root cause of 90% of web application vulnerabilities is that the application does not properly validate user input. Now, what does that mean? Well, it means having no or inadequate defenses in place that ensure that the input that is coming from the client side is not malicious. And that's exactly the case for directory traversal vulnerabilities. On the screen here, I've got sample vulnerable code. What I would recommend is that you pause the video right now and try to figure out which line of code is vulnerable. And once you figure out which line of code is vulnerable, what I would recommend is that you attempt to come up with an exploit to see how you would exploit this vulnerability. All right, hopefully you figured it out. If not, it's okay. We'll go through this together. So you can see over here, we've got a PHP application. On line number 2, the first thing that we do is initialize a variable called template. We set it to the value blue.php, and then we've got an if statement. In the if statement, it asks, is the cookie template set? So does it exist? Is it empty? If it's not, then we set the content or the value of the cookie template to the variable template that we just initialized. And then on line number 5, we use the include statement to include and evaluate the file path /home/users/phpguru/template/ whatever the value of the template variable is. Now, the issue over here is that this variable, so the template variable, is user controllable because it's coming from the client side. So it's coming from a cookie that is set in the browser, and it's not validated in any way in the backend. So me as an attacker, what I could do is I could exploit this vulnerability using this request over here. So you could see over here, I've got my template cookie, which is coming from the client side. What I do is I add a directory traversal payload in order to exploit the vulnerability. So this is a very common payload for directory traversal vulnerabilities. You could see we've got a dot dot slash, which means move up a directory, and then another dot dot slash, which again means move up a directory until we reach the root directory, and then we're calling the passwd file, which exists in the slash etc directory. Now, what happens when the application receives this request is that it'll go to the piece of code that is responsible for the request, which is this one over here. It'll set the content of the cookie template, so our payload, to the template variable, and then it'll include it over here. Now, once it's appended to this path over here, the dot dot slash, so the path traversal sequence, will get us out of this directory, and then the next dot dot slash will get us out of this directory, and then this directory, and this directory, and so on, until we reach the root directory, and then all it has to evaluate is the slash etc slash passwd file, and it displays the content of that file for us. And that's how simple this vulnerability can be. Now, it's worth mentioning that we specifically picked the passwd file because it's world readable, which means that regardless of the privileges the application is running with, we'll be able to view the content of that file. If the application was running with, let's say, root privileges, which is against the concept of least privilege, but let's say it's running with root privileges, we would be able to exploit the vulnerability to view even more sensitive files, like the shadow password file, which stores the hashed passwords of local users on the system. And that's why it's really important that you always run your application with the least privilege possible, because it works as a defense in depth mechanism. All right, let's discuss the impact of directory traversal vulnerabilities. We've touched a bit on that in the previous slides, but as usual, when I discuss impact, I like to measure it in terms of how it impacts the SIA triad. So confidentiality, integrity, and availability. Now, in terms of confidentiality, that's usually impacted because directory traversal vulnerabilities allow you to access and read files on the server. However, it's not that clear when it comes to integrity and availability. So some directory traversal vulnerabilities allow you to call programs that have the ability to execute commands. And so you could use the directory traversal vulnerability to run commands. And therefore, in a sense, for integrity, you're able to alter files on the system. And for availability, you're able to delete files on the system. But the idea over here is that in that scenario, you technically have full remote code execution on the server, because if you could execute commands, then you could just upload a shell on the server and then RCE the server. So in that case, confidentiality, integrity, and availability would all be set to high, and the vulnerability would end up likely rating at a critical. Okay, so we talked about the potential impact of directory traversal vulnerabilities. Now the question is, how common and how critical are directory traversal vulnerabilities? One way to measure that, and it's not bulletproof, is the OWASP Top 10 list. So for those of you that have not heard of the OWASP Top 10 project, it's essentially the list of top 10 most critical security risks facing web applications today. It's updated every couple of years, so you could see we've got a list from 2013, and then a list from 2017, and the latest list, which is from 2021. And as you can see, directory traversal does not have its own category in the OWASP Top 10 list, but it does fall under the overall category called injection, which is considered the third most critical security risk facing web applications today. Of course, injection covers a ton of vulnerabilities, not just directory traversal, which is why we can't really categorize directory traversal as the third most critical security risk facing web applications today. But regardless, we did see that directory traversal vulnerabilities allow you to read files on the server, and in worst case scenarios could even give you remote code execution on the server. So definitely something to be careful of, and definitely something that you need to test your application for to ensure that you're not vulnerable. Alright, in the past couple of slides, we discussed what directory traversal vulnerabilities are, their impact, and how common and critical these types of vulnerabilities can be. In this section, we'll discuss how to find directory traversal vulnerabilities. So imagine you've been given an application and asked to test it. How would you go about testing this application to see that it's vulnerable? I've decided to split this section into two categories depending on the perspective of testing. The two categories are black box testing and white box testing. For those of you that have never heard of these terms before, black box web application pen testing is when the tester is given little to no information about the system. Usually, the only information that the tester has access to is the URL of the application and the scope of the engagement. Whereas for white box web application pen testing, it's the complete opposite. The tester would be given complete access to the system, including access to the source code of the application. Now, there's a third category that I haven't included on the slide. It's called gray box web application pen testing. This is a combination of both white box and black box pen testing where the tester is given limited information and access to the system. So for example, instead of just giving the tester a URL to the application, the tester is also given accounts to the application to test with. When it comes to my methodology for finding directory traversal vulnerabilities, I loop both gray box and black box pen testing into one category, and that's because my methodology is the same for both categories. If I'm approaching it from a black box perspective, my scope will be much more limited than the gray box perspective, unless I find an authentication bypass vulnerability. Nevertheless, the methodology of testing for these types of vulnerabilities from an unauthenticated perspective and an authenticated perspective is the same. So for this presentation, when I talk about the black box testing perspective, what I really mean is gray box. We're going to assume we're given a URL to the application and accounts from each privilege level to test with. Alright, let's start off with the black box perspective. The first thing that I do when testing an application is map the application. What that means is I literally visit the URL of the application, walk through all the pages that are accessible to me within the user context that I'm running as, and make note of all the input vectors that could be potentially used to retrieve data from the server file system. So that could be any parameters that contain, let's say, the name of the file or the name of a directory. Once you've identified all the instances, it's a matter of testing or fuzzing these instances with common directory traversal payloads. On the slide, I've got sample directory traversal payloads. Some of them are for Linux, others are for Windows. If you go online, you could get huge lists that contain tons of payloads that could be used to test for this type of vulnerability. But the idea is that you submit the payload and you analyze how the application responds. If the application responds in a way that it's not supposed to, like outputting the content of a file you requested, which would be the best case scenario, but in other cases, it generates a verbose error or it even responds with a different status code, then it's a matter of really just fine-tuning your payload until you can successfully exploit the vulnerability and get the application to output the content of the file from the server. Now, this is something that you can definitely do manually. However, it does become tedious and you might miss stuff, so it's not as accurate. And so usually you use a web application vulnerability scanner to automate the process for you. We'll talk more about that in the next section when we discuss how to exploit directory traversal vulnerabilities. Alright, so that's how you would do it for a black box perspective. Let's move on to the white box perspective. The first thing that you want to do here is identify all instances in the application where user-supplied input is being passed to file APIs or as parameters to the operating system. This can be done in many ways. The first way that you could do that is a mixture of both black box testing and white box testing. This is the method that I personally apply when an organization gives me access to a running application and the underlying source code for the application. So what I do is I first map it from a black box perspective and I identify all the instances where the application could be potentially interacting with the server's file system. And then I focus only on reviewing the code that is responsible for these parameters or these instances instead of reviewing all the code in the application. The second option is to grep on certain functions that are known to include and evaluate files on the server, and then reviewing if these functions take any user-supplied input. If they do, then maybe check if any validation is in place to ensure that malicious input doesn't go through. The third option is if you have local access to the application. What you could do is use a tool to monitor all file system activity on the server. So test every page from a black box perspective by inserting a single unique string in each parameter at a time, and then filter your file system monitoring tool to identify all file system events that contain that specific unique string. If you see any events, then for sure the application is interacting with the file system, and so you test the application or you review the code to see if it's vulnerable to path traversal. Of course, regardless of which method or combination of methods you want to use, you always have to validate that the application is vulnerable by entering your exploit payload in a running application. And that brings us to our next section, which is how to exploit directory traversal vulnerabilities. The most common way you'll encounter when exploiting a directory traversal vulnerability is the one you'll see on this screen. This is the regular case where there is no validation whatsoever in the backend. So what you could do is use the path traversal sequence, which is the ... to traverse out of the current directory that you're in and try to access a world readable file like the passwd file or the win.ini file for Windows. This is the case where there's no validation. Now, in other cases, you'll encounter inadequate validation that was put in place by the developers. This would hinder your ability to exploit the vulnerability, but does not make it impossible. So the first way that I've seen is developers stripping out all path traversal sequences. So again, the ... And in that case, what you could do is you could try to put the absolute path of the file that you want to read and see if that works. So instead of using ... and then ... and so on, and then the path to the file, you just use the absolute path and see if the application accepts and is able to evaluate that. If that doesn't work, then you could enter the following payload. This will only work if they're non-recursively stripping out the traversal sequence. So over here, we've added some characters in rad. And what will happen is if the application is non-recursively stripping out the traversal sequence, it'll remove all the characters that are in black. And so what we end up with is our regular case directory traversal sequence, which should work since they're not recursively removing the traversal sequences. Another thing you could try is URL encoding the payload or double encoding the payload. You could even use non-standard encoding to bypass defense mechanisms. Another case that I've seen is the application requiring the parameter to start with a specific path. So let's say the var dub and then images path. In that scenario, this path would be included in the parameter, so you don't really have to guess it, and the way you would exploit it is just keep the path in the parameter and then use your regular directory traversal payload to view the file. Last but not least, some applications require the file to have a specific extension, and in that case, you could use the null byte, which is represented by a %00 sign in hex, to tell the application to ignore anything after the null byte. This way, you could include the required file extension and use the null byte to ignore it. Of course, this doesn't work for all frameworks and programming languages. It would require the framework and the application to be able to process the null byte and then ignore everything that is after it. Okay, so in the next 6 lab videos, we'll gain hands-on experience in every case that we saw in the previous 2 slides. Alright, so far we only discussed how to do things manually. We can't end this section without mentioning web application vulnerability scanners. Web application vulnerability scanners are essentially automated tools that crawl your web application and look for vulnerabilities. Most scanners have the ability to test for directory traversal vulnerabilities and have inbuilt payload lists that are specific to this vulnerability, which is why I highly recommend using a scanner to test for this type of vulnerability because it's way more efficient and way more accurate than having to do it manually. Okay. Let's move on to the last section, which is how to prevent directory traversal vulnerabilities. The best way to prevent directory traversal vulnerabilities is to avoid passing user-supplied input to file system APIs altogether. So in majority cases, this can all be implemented in the backend, and you don't really need user input to access the file system. However, if that's not avoidable, then you can use a combination of 2 layers of defense to prevent this type of attack. The first one is to validate user input by comparing it to an allow list of permitted values. And if that's not possible, then make sure that you only accept user-supplied input that contains alphanumeric characters and no other characters. Now, once you're done validating the user input, the second layer of defense is to use file system APIs to canonicalize the path and verify that it starts with the expected directory. So if all your files are, let's say, in /var/www/images directory, then the request for a file has to absolutely start with that path and nothing else. On the slides over here, I have sample code from the Portswigger website on how to do that in Java. Of course, again, you have to do these two layers of defense together. You can't just apply one of them and expect to not be vulnerable to directory traversal vulnerabilities. Okay, we've reached the end of the presentation. I added several really useful resources on the slide in case you're interested in learning more about directory traversal vulnerabilities, and I've included the link to the slides in the description. In the next few videos, we'll gain some hands-on experience exploiting these types of vulnerabilities.